I will be discussing some basic terms from shear force and bending moment diagrams related to shear force and bending moment diagrams. What is shear force, what is bending moment, and what are the salient features? We will discuss all these things briefly in today's session. So first of all, the shear force, mainly in beams where the loading is transverse to the axis. Loading is perpendicular to the axis. We come across the shear forces. Shear forces are the tangential forces actually, which act on the cross section, along the cross section. Okay, wherever you cut, you will have forces acting along the section. So the net force acting on a cross section is said to be the shear force. Tangential force acting is said to be the shear force. It will have the shearing action actually. That means the failure will be something like this under the action of shear. Yeah, once one part will slides something like this. Okay. Yeah. So if the failure takes place due to shear, that will be in this form. That means the failure of cross section to resist the shear force. So it occurs at the weakest cross section. Okay. So when beams are designed, the shear force also is to be taken care. Okay. It is to be kept in mind while designing the section for shear forces. Okay. So, and it is calculated at any section, the shear force is calculated as the sum of all the forces acting either to the left or to the right. One side will consider, okay? So, at any section, you may have two values. You may have two values, one positive, one negative, okay? So the maximum one is to be taken care, okay? Yeah, in the design, okay? Algebraic sum of all the vertical forces, including reactions, okay? Acting either to the left or to the right of the section. That is said to be the shear force, okay? Actually, it is the internal resistance offered by the material of the beam. Okay, to sliding or shearing along that section. Okay, and it will have the units of force, that is Newton or kilonewton. Okay, yeah. The shear force is perpendicular to the longitudinal axis. That means it acts in a transverse direction. Okay, perpendicular to the axis. That means parallel to the cross section actually. Shear force tends to cause one portion of the beam to move vertically. Okay, with respect to the adjacent portion. You will have shear force in vertical members also due to horizontal forces. Because here the axis is vertical in case of columns. Because of this horizontal forces, we will have shear. Okay? We will have shear. And these horizontal forces are mainly due to wind or earthquake. Okay? Wind or earthquake. So, columns are also to be designed for shear, okay, keeping in view the wind forces and earthquake forces in case of tall structures, okay. Yeah. And how about bending moment at a section? Yeah, again we consider the beams subjected to the transverse loading. They bend like this, okay. So the bending moment at any section is calculated as the algebraic sum of the moments of all the external forces, including reactions, acting to the left or to the right of the section, about the section point here, okay. The bending moment about this section, okay. Here the bending moment is only it will have only one value, either negative or positive. At a particular section you will have only one value, bending moment, either positive or negative, unlike shear force. Shear force may have positive or negative moment. Actually, at the under the load points generally, okay, you will have sudden drop, sudden change in the shear force. In case of bending moment also there will be sudden drop in case if it is subjected to a couple, okay. In case if it is subjected to a couple, then you will have sudden drop in the bending moment at that section, a drop or rise we can say, okay. Is this clear? So bending moment is the resistance, actually resisting moment, okay, internal resisting moment. That is to resist the moment due to bending due to the external loads, okay. The bending moment here causes the rotation of the axis, rotation of axis as shown here. Axis bends, isn't it? That means it rotates by some angle. That depends on the stiffness, okay. That depends on the stiffness. The deflections depend on the stiffness of the member. Stiffness means which depends directly on moment of inertia, the cross section, okay, and moment of inertia I. If it is a rectangle with the dimensions BD, then moment of inertia is BD cubed by curve, okay. So the stiffness depends on moment of inertia, okay. So this is bending moment and is calculated as the algebraic sum of moments of all the external forces, including reactions, acting either to the left or to the right of the section, okay. And it will have the units Newton meters, that is force into distance. Moment is force into distance, so it will have the units of Newton meters or kilonewton meters, bending moment, okay. And at the point of zero shear, you will have the maximum bending moment, okay. At the point of zero shear, you will have the maximum bending moment. In other words, where the shear force changes sign, we will have maximum bending moment at that point. And coming to the convention, sign convention for shear force and bending moment. So this is the horizontal beam. You consider a section of elementary width, small width. Okay. Now we will have different forces acting. Okay. Now to calculate shear force at this section, if the forces on the left side are upwards, okay, they are considered positive. Left side upward forces are considered positive, and right side downward forces are considered positive. Left side upwards and right side downwards, right side of the section. Okay. So if the forces, when you calculate the sum, you have to take this sign convention. Okay, you have to follow this sign convention. If the forces are upwards on the left side, we have to take them positive, and downward will be negative. Left side up downwards are positive, and left side upwards are right side upwards are negative. Right side downwards are positive. So we can simply write like this: left of the section upward, right of the section downward are positive, and left side downwards and right side upwards are negative. Okay, opposite to this is negative. Okay, yeah. So you have to follow this convention throughout a problem. Some may take otherwise also. That means they may take left up, right down negative, and left down, right up positive. It doesn't matter, but we have to follow it uniformly throughout the problem. Okay. Is this clear? Yeah. So negative shear causes counterclockwise movement, counterclockwise rotation. Negative shear here is left side downwards, which causes counterclockwise rotation. Counterclockwise rotation, isn't it? And positive shear causes clockwise rotation. Positive shear, that means right side downwards is positive, left side upwards is also positive. So this causes clockwise rotation. Okay, and this causes anti-clockwise rotation. Negative shear causes anti-clockwise rotation, and positive shear causes clockwise rotation. Okay, yeah, this is very important while solving the problems. Okay, sign conventions are very important. Okay, yeah. And for bending moment, also we have to follow some sign convention. Okay. So bending moment is positive when it causes compression at the top of the beam. So actually, this is the beam, isn't it? A simply supported beam. So downward forces cause it to bend something like this. Okay. Is it? Yeah. Causing compression at the top. In case of simply supported beam, the loads cause compression at the top, causing sagging. This is the sagging. Okay, this is called sagging shape. The axis bends downwards like this. Okay. So this is considered positive. Okay, this is considered positive. That means sagging moment considered positive. Sagging means convexity downwards, concavity above, convexity below. Okay, convex surface lies below and concave surface lies above. Compression at the top and bottom fibers are subjected to tension. Top fibers are subjected to compression. So this is called sagging. Okay, and the corresponding moments are called sagging moments and are positive, considered positive. Okay, and where do we come across negative? Which causes compression below and tension above. Compression at the bottom, in the bottom fibers, and tension in the top fibers. Where do we come across this type of bending? Okay, yeah, think of it. We come across this in case of cantilevers directly, we can say. Okay, cantilever, beam which is fixed at one end and free at the other end, isn't it? So under the action of transverse loads, beam bends downwards like this, causing tension in the top fibers and compression in the bottom fibers. Okay. This is and this type of bending is called hogging. This is sagging. And this movement is called sagging movement, hogging movement or negative movement. It is considered negative. Okay, as per the sign convention. The movement which causes tension above and compression below. Tension at the top in the top fibers, compression in the bottom fibers is considered to be negative. Okay, we can see this type of bending in cantilevers or in continuous beams also. In the continuous beams at intermediate supports, the bending will be something like this. Okay, yeah. So above this support, above the intermediate support, we will have beam bending such that it will have tension above and compression below up to certain distance on either side of the support. That means the curvature changes from positive to negative. Okay, that means the moment changes from sagging to hogging, sagging to hogging, and the point where it changes the sign is said to be point of contraflexion. This is called point of contraflexion or point of inflection. Point of contraflexion or point of inflection. Okay, that is the point where the bending moment changes sign. Okay, bending moment changes sign from positive to negative, from sagging to hogging. Sagging is positive, hogging is negative. So bending moment changes sign here in continuous beams at the intermediate supports. But in simply supported beam, we will have only positive bending moment without overhang. In a simply supported beam without overhanging, you will have only positive bending moment, no negative bending moment. Similarly, in case of cantilever, we will have only negative bending moment and no positive bending moment. Okay? And in case of continuous beams or simply supported beam with overhanging, we may have negative bending moment. Okay, we may have negative bending moment also. This clear? Okay. Yeah, the point of counterflexure, just now we have discussed. Point along a beam where the bending moment changes its sign. It means from positive to negative. That means the curvature changes. Okay? Side. Yeah, at this point, bending moment is 0. As it changes sign from negative to positive, the bending moment is 0 at the point of counterflexion. And then it changes the direction of curvature. That means from sagging to hugging or vice versa. And it is an important consideration in continuous beams and propped cantilevers. Cantilevers with overhangs means propped cantilevers. Okay. Now, shear force diagram. What is shear force diagram? In a horizontal beam, okay, consider a simply supported with the different loading. Okay, different types of loads active. Okay. How to draw the shear force diagram? Actually, what does this diagram show? It shows the values of shear force at different sections along the beam. Okay. For that, what you have to do, we have to consider different sections. Okay. To calculate the shear force, we need to consider different sections between every change of load. Okay. Now, considering these sections, for example, this is section 1, section 2, 3, 4, and 5. When you consider section 1, these are the reactions. First, we will calculate reactions in a simply supported beam. Before drawing shear force diagram or bending moment diagram, first thing is to calculate the support reactions by using equilibrium conditions. Okay, equilibrium conditions. So once you find reactions, now you consider a section between point A and point C. Because there is a point load applied at C, we consider one section between A and C. Now the shear force at this section, to calculate shear force at section 1, what you have to do, we have to consider either left side of that section or right side, any one. Generally we consider here left side because there are less number of forces to the left compared to right side. Okay, nothing, it is just summation of forces either to the left or to the right. Okay, yeah, for that also we consider left side here because there is only one force, that is the reaction RE. So shear force at section 1 is nothing but RE. Is it positive or negative? For that we have to follow the convention. Already we have seen left side upwards and right side downwards are positive. So here the considering left side, so RA is upwards, so it is positive. Shear force at A or to section 1 is positive. Okay. Yeah. If you observe, there is no force between A and C. Okay. That means the shear force between A and C is independent of the distance of the section. If the section is at a distance x, okay, so x0 or x equal to, let this distance is a, small a, from a to c. Yeah, between a and c, x varies from 0 to a. Correct? So when x is 0 or x is equal to a, shear force will be the same, that is RA, because it is independent of distance. So at x equal to 0 means shear force at A equal to RA. At x equal to C means shear force at C, that is also RA. And one more thing is, when you consider the portion AC, we consider the section between A and C, isn't it? When you consider the portion AC, then this section, when at x equal to A, the section is considered just to the left of C. Okay, just to the left of C. In that case, we will have shear force at C equal to RA. What happens when the section is just to the right of C? For that, we consider this. Between C and E, if you consider a section 2, then when the section is at C, that will be just to the right of C. That is to be taken care. Okay. In the case of section between C and E, at x equal to A, x is again taken from A. At x equal to A means section is at C, but at C means not exactly at C, it is just to the right. Okay. In that case, you will have the load W1 also included, because we are considering left side. What are the loads to the left of section? RA and W1. Okay. So shear force at section 2 in portion CE is RA minus W1, because left side upwards is positive, RA is positive and W1 is negative, as per the sign convention. Okay. So like this, we calculate the shear force values along the span of the beam at salient points, and we plot the diagram. That diagram is said to be the shear force diagram. And at the point of zero shear, where at any section, if the shear force changes sign, then you will have maximum bending moment at that section. Okay, maximum bending moment at that section. Same is the case with the bending moment diagram also. We calculate bending moment at different sections. Okay, and plot the diagram, which is called the bending moment diagram. And how to calculate bending moment? For this also, we consider different sections between different points where the load is changing. Okay. Yeah. Number of sections depends on the number of load changes that takes place. Okay. So why we need to consider different sections means the equation for bending moment changes. Okay. Because between A and C, say, the bending moment is, if distance is x, RA into x is the bending moment at section 1 between A and C. If you consider between C and D, section between C and D, then the bending moment at section 2 is, this is section 2. What is it? RA into x minus W1 into x minus E1, where x is again measured from A. X is measured from A. Is it? So the equation for bending moment will be different between different sections. So we need to consider number of sections, and we calculate bending moment at different sections, substituting appropriate values for x, and we plot the diagram. which is called bending moment diagram, which shows the bending moment at different sections for the given loading along the span. Okay, bending moment at different sections along the span for the given loading. Okay, and that's all for now. We discuss remaining terms in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.